Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 46 from the Smith Organic Chemistry textbook. And this problem asks us to predict the products of three reactions. And so at first glance, the first thing that I see here is that each of these is the formation of a Wittig reagent and then reaction of that Wittig reagent with a carbonyl compound. And so we should remember from this chapter that the way that the book likes to form Wittig reagents here is to react an alkyl halide with triphenylphosphine and then treat that with butyl lithium to get to the active Wittig species and then react that Wittig species with a carbonyl compound. And indeed, we see for each of these reactions, it's literally that. It's treatment with triphenylphosphine, followed by treatment with butyl lithium, followed by treatment with a carbonyl compound. And so each of these products is going to be the alkene formed by reaction of the Wittig made from our starting material and the carbonyl that is always listed as the third reagent for each of these problems. So bearing that in mind, it pretty much just becomes a fill in the pieces type deal. And so one strategy to approach this might be just to write the alkyl halide, the alkyl group from the alkyl halide that's going to end up contributing the left half, as you might think of it, of the product, and then writing the piece that's going to come from the carbonyl compound. So like that, and then just connecting them with a double bond. And so that's one sort of easy way or shortcut to arrive at these answers here. Once you've identified that that's the process that's going on, that it is formation of a Wittig and then just a Wittig reaction. And so we can do the same thing for each of these. One thing to bear in mind if you do choose to approach these this way is just that you're always going to lose a hydrogen here. So you can see it's CH3CH2 in the starting material, but CH3CH in the product here. So that is one thing to just be mindful of as we solve these next two. And so using that same approach, B is going to look like this. So there's the portion that comes from our starting material, and we can actually write that out as CH if that makes it easier. And then the portion that's going to come from our third reagent in the sequence that we're given is going to be CH, CH2, CH2, C6H5, C6H5, and we can just connect them with a double bond there. And we should also note we're going to get the E and the Z isomers here. So E and Z. And of course, in A, it's not really an issue since the right half of the molecule has identical substituents. So E and Z are going to look the same. There's not going to be a difference there. Okay, and then for C, it's just going to be more of the same here. So we're going to form the Wittig from our starting material and then react it with this carbonyl that we're given as the third reagent. So following that same sort of methodology, so here we can just put CH if that's easier than just leaving it in typical line notation. And then we can draw, again, the right half that's going to come from our carbonyl compound, reagent 3 here. It's going to be CH, CH2, CH2, CH3. CH2, CH2, CH3. And then again, we're just going to connect these two by a double bond. And again, we should note that here as well, we're going to see both the E and the Z. So cis and trans stereochemistry around that double bond. Yeah, okay. And so again, I think the key to solving this problem is just to look at the reagents and recognize that each of these is the formation of a Wittig and then a Wittig reaction. And then once you've done that, you know that the product of a Wittig reaction is always an alkene. And you know how the two pieces of these molecules, these product molecules, should be joining up. So you can just draw out each piece and then connect them by a double bond, or however it's easiest for you. Yeah, but so that's the answer to chapter 21, problem number 46.